Hello students, today I am going to explain to you A, B, C, D, 4 parts of question number 2 from this paper. Okay, this is May 2024 TZ-1. Right, I'm sorry that I could not post second question because there was some incident, sad incident in my family. So no problem. Let us start now. Right, so I will go to question number 2, page number maybe 8. No, it is further. Yeah, here is question number 2. It says it is for maximum 28 marks. This question investigates a ratio of lengths found from the line passing through the points of inflection of a quadratic curve of the form y is equal to x to the power 4 minus mx cubed plus nx. Right? The curve y is equal to x to the power 4 minus 3x cubed plus 3x has points of inflection B and C. So here B and C are points of inflection. The line passing through B and C intersects the curve again at points A and D. This is shown in the graph. See, A and D also are the points which are on the line passing through the points of inflection B and C. Now let me tell you something about points of inflection. See, when you find dy by dx and take it equal to 0, this gives you the stationary points, right? Or turning points, stationary points, right? But when you find d2y by dx square, and if it is less than 0, it gives you maximum point. And if d2y by dx square is greater than 0, it gives you minimum point. And in the case when d2y by dx square is equal to 0, it gives you points of inflection. Okay. So this is the thing we have to remember. We are going to use this. You know that before point of inflection and after point of inflection, okay, the curve has different turning point. I mean concavity up here, concavity down here. So this is point of inflection. C is also point of inflection, so it is concave down before it and it is concave up after it. Okay, so let us see A, B, C, D parts. I'm going to part A. It says find d2y by dx square, means second derivative of this curve we have to find. So I will differentiate one time. I will get 4x cubed because 4 comes here and minus 1 from the power, so we get 4x cubed. Then minus 3 into 3 will come here. Okay, so 3 3 is a 9, minus 9x square, and then 3x will become 3. Right, this is first derivative, and then second derivative will be again differentiated with respect to x. So 3 will come here, 4 times 3 12, x square 1 less from the power, and then 2 will come here, 9 times 2 18x, right, 1 less from the power, and 3 will become 0. So this is the second derivative. Find the coordinates of B and C. Now remember that B and C are points of inflection. So at B and C, d2y by dx square will be 0. Okay, so it means 12x square minus 18x is equal to 0. 6x is common factor, so 2x minus 3 will be the second factor. So therefore x is equal to 0 at B and x is equal to 3 by 2 from the second bracket at C. Look at the curve. At B we have, okay, at B we have 0 and at C we have 3 by 2. Right. Now, second part we have done. Third part, C part says, show that the equation of the line through B and C is this. Look here, equation of line through B and C, through B and through C. Because B lies on the at the origin. Okay, so line is passing through the origin, therefore y-intercept will be 0, right? We will have only the gradient. So equation is of the form y is equal to mx, right? So m we have to find. Now, how can we find m? Because the line is passing through B and C. Sorry, here we had to find the coordinates. Okay, so I have to find the y coordinate also. So therefore, because B is the origin, therefore it will be 0, 0. And C will be 3 by 2. And I'll put it in the curve, original curve, 3 by 2 into this curve and get the y coordinate. So 3 by 2 to the power 4 minus 3 into 3 by 2 to the power 3 plus 3 into 3 by 2. And I'm going to get, yeah, by calculator, minus 9 by 16. So these were the 2 points. Now using those 2 points, I can find the gradient of this curve. So m is equal to minus 9 by 16 minus 0, y2 minus y1 over x2 minus x1. So I am using these 2 points. This is x2 y2, this is x1 y1, right? So y2 minus y1 over x2 minus x1. This is the formula for the gradient. So I'm using that and getting the value of m. So it will be 0.375, right? So that will be the gradient. Therefore, equation of line BC is y is equal to, sorry, minus here. So minus 0.375x. Okay. So this is the equation of the line, right? Now, next part, D part says, find correct to 3 decimal places the x coordinate of D. Look here. The line we have found just now, this line, also passes through D, which is the 4th point on the curve and the line. So we have to find the point of intersection of the line we have found and the curve. So we have to solve them simultaneously. Okay. So solving y is equal to minus 0.375x, and I will copy that curve here. Okay. Right. And I'm going to solve them using GDC, okay, in graphical mode. So that will give me easily the point of intersection using GDC. My GDC is Casio CG50, and look here, I have put on the calculator, and now my point of intersection is this one, right? Look here. So the 4th point I wanted, this is that 4th point. Its x coordinate they want. So x coordinate to 3 significant figure will be 2.427. So at D, x is equal to 2.427. Okay, then I'll stop here. Bye for now.